So I will just continue further with my previous video. With respect to that, I will continue this in this video, nucleophilic substitution reaction. So in my previous video, it was A and B. Now it has come to C. So here the substitution, suppose say if it is taken like this, action of sodium alkoxide. So this sodium alkoxide can be written as RONA. RONA. Say if we have here RX. Okay. Let me explain this with respect to different colors. So if I treat this with say NaOR. Okay, now why I wrote like this Na first? Actually it is RONA. I have written Na first here to show that what can go out from here, looking at this only can be got. Na and X will go out. What will be left there? ROR. So what we get here, the compound from this will be, the compound that we get here from this will be R. I will show as it is in terms of same color so that you can follow it properly. R with O and here R plus Na with X. Okay, so this compound that we get is called as ether. This is known as ether. Alright. Now this ether is having both the R group same. R group here and R group is same. This is called as simple ether, simple or symmetric ether. It is also called simple ether or it is also called symmetric ether. Example of this I will give. C2H5 say I. Treat this with Na say NaOCH3. I'll write the names of this. This is iodoethane. Iodoethane. This is what? Sodium methoxide. Sodium methoxide. Okay. Now, what will go out from here will be as it is. So what we'll get here will be C2H5 then O with CH3 plus NaI. What we'll get here will be Na and I. Now here if you look at this is C2H5 group, one R group. This is another R group. This group and this group attached between the oxygen here is not the same. Therefore, these two groups are being not same. This will be called as unsymmetric ether. This is called as also mixed ether. So this will be named as what you know, methoxyethane. Or common name of this will be ethyl first and then methyl. Common name when we write, you have to see alphabetical order. That is also followed for IUPAC nomenclature, no doubt. So this is what here first I'll write ethyl, then methyl, ether. This is common name. And IUPAC name is what? Methoxyethane. That higher group, remember that the alkyl group which is containing more number of carbon, that should be ended as alkane. Here more number of carbon is ethane. Therefore you have to end it as ethane. I hope you will understand when you refer, okay, properly. So methoxy, what here? Ethane. Alright. Now this ether is the unsymmetric ether. This is what I wrote here, ROR simple. I'll give another example. Based upon this, what you take. Suppose I have taken here methyl chloride. treated with, say, sodium and CH3. This is called what here? Sodium methoxide. Okay, sodium methoxide. What will go out from here will be NaCl, and therefore you will get here CH3O, CH3 plus NaCl. Now what you can observe over here, that both the alkyl group attached to the oxygen here are same. Therefore this ether will be simple or symmetry. Now this will be called a what here? Either I can call it a dimethyl ether. See, either I can call it a dimethyl ether, or simply I can say methyl ether. There is no need of repeating dimethyl ether. You can say, call it as just what? Methyl ether. And dimethyl ether, even if you say not wrong, so dimethyl ether. IUPAC name become what here? Methoxymethane. Methoxy. This group is containing one carbon beside with oxygen. Therefore, this is called methoxy. Then the other part should be changed to alkane. So alkane one carbon is what here? Methane. Methoxymethane. Okay, so remember how the name is also given. Now this reaction is having a name that is called as Williamson synthesis. This is referred as Williamson synthesis. Alright, so please follow what we are talking about, Williamson synthesis. Alright, then next we go for D. Suppose I have written here action of silver cyanide. Now here please remember properly, I have given earlier potassium cyanide. In my earlier video, I have explained how the action of potassium cyanide. Now I will first write down and see. Suppose say Rx if I add here, and to this if I add here silver cyanide. According to anybody, if you just see, what we will say that silver and X will go out as AgX. No doubt, it will go out as AgX. But the group that will be left here will be, the group that will be left here will be RCN. But here it will not be RCN. This will become RNC. See this, this will become R with NC. This is a particular case. So what I have shown here with an asterisk. When I had used potassium cyanide, directly it was becoming RCN. If you look at that previous video of mine, then you will understand in a better way. See, RCN, the same can become what here? R and C. If it was K, I'll just write here so that you can recollect that in that other video of mine. So you can see here Rx plus KCN alcohol. Alright, alcohol. What we'll get here will be RCN. Of course, other one is KX. Now here, silver cyanide, it is not RCN, but it will become RNC. This is called as alkyl isocyanide. Plus, of course, the other group is AgX. Main reaction you have to see. Now this is called as isocyanide group. Now what that cyanide group is called as ambident group. Remember, cyanide is ambident group. So in that ambident group, remember the linkage to the carbon mean alkyl group here, because alkyl group also has carbon. So this linkage can take place either from carbon or from nitrogen. So please remember this. I will write it like this. Linkage can be this way or linkage can be this way, either way. Okay. So if it is linkage to the nitrogen, it is called as iso. And if it is linkage to the carbon, directly cyanide. Okay. So when you have a silver cyanide, this part you remember very well. When you use silver cyanide, the linkage is from nitrogen. Therefore, what you'll get is isocyanate. I hope you just follow this properly and understand. Okay, be clear about what you all are doing. And for that part, you have to just practice it. You have to write down. Unless you write down, just don't admire or listen to the video. After that, you just see, after listening to this video or seeing this, all this, try to write down by your own. Develop the practice of writing. And if you write down, you will understand better way. Okay, and not forget. So remember here, cyanide group here is ambivalent group. Huh? So what is ambivalent group? It has got the two different ways of linkage. There are some other group also. One I have given now today, cyanide. I will not confuse. So what we'll get here will be CH3 with NC plus AgCl. This is called as methyl isocyanide. Methyl isocyanide. Or you can also call like this. This carbon you take, this carbon also if you take, it will become ethane. Ethane isonitride. That is another, that is IUPAC name. Ethane isonitride. Okay, ethane isonitride. Alright. Then the next reaction we will see E. So here remember very well silver cyanide. Remember silver cyanide. Suppose if I have taken here action of, let us take here say ethyl or ammonia. Let us take ammonia. Remember I told you ammonia is what? Ammonia is a nucleophile. So action of ammonia. So Rx, please follow this. It is easy. Not that important, so I will not stick this much. Alcohol and heat. There is one more chapter called amines. In that chapter you will study this in detail actually. So what you will get here, see H from here, NX from here will go out, and what you left there will be RNH2 plus HX. Of course, actually this is amine, and this amine can react with the acid and form a salt RNH3X. and H to become X. So anyhow, I'll write here primary amine. What you get here is primary amine. Okay, amine E. Primary amine. So this reaction I am not going in detail because you will be learning this in the next chapter called amines. Okay. Alright. So in this video, please remember the different action of what? The different reagents which are nucleophile. So this reaction up till E I have shown here in my video. It is not ended. There is more reactions are there which are substitution reactions which are nucleophilic. Okay. So we will continue in my next video. I will explain to you about the nucleophilic substitution reaction.